These are Lesson 8.3 Notes Logarithmic Functions. Today we're going to convert between exponential and logarithmic forms. We're going to evaluate some exponential problems that you probably should know. We'll evaluate logarithms and we'll solve problems involving something called pH and acidity. First thing we're going to talk about is the difference between exponential and logarithmic forms. We have a little statement here. It says if y equals b to the x power, then log base b of y equals x. These two statements are basically saying the same thing. It's sort of like saying goodbye and adios. They look different, but they're basically getting to the same point. In exponential form, what we have is we have something like b to the x power equals y. This is called exponential form because x is in the exponent. A problem written in exponential form has an x in the exponent. A problem written in logarithmic form does not have an x in the exponent. The x is basically out front, and what we say is we have this log base b of y equals x. In exponential form, the base is the value that's kind of preceding the exponent. In logarithmic form, the base is what the log is being taken of, so we have this log of base b. It's like a subscript. And notice that kind of the x and y change positions. In exponential form, it's b to the x power. The b and the x are next to each other. In logarithmic form, the b and the y are next to each other. So if we have the statement 36 equals 6 squared, 6 is your base, 2 is your exponent. In logarithmic form, what we would say is log. We take the base, which is the number before the exponent, in this case, which is 6, so it becomes our subscript. The exponent 2 is not written next to it this time. The exponent goes on the other side, and the 36 goes next to this 6. So we have the log base 6 of 36 equals 2. For 10 to the third power equals 1000, our base this time is 10. The exponent is 3. So when we write this problem, we're going to say log. The base is the number that's before the exponent, so it's going to be log base 10. The exponent 3 goes on the other side of the equation. And the 1000, which was kind of like our y value, that goes next to our base this time. So in logarithmic form, the statement 10 cubed equals 1000 would be written the log base 10 of 1000 equals 3. Now, as a little shortcut you can use, anytime that you write log base 10, because this comes up actually a lot in real life mathematics, what we often say is that this can be written as just the log of 1000 equals 3. If the base is 10, you basically don't have to write it, which is kind of nice. What I'd like you to do is I'd like you to see if you can figure out the logarithmic form for 5 cubed equals 125, and then see if you can work the other direction and take these problems written in logarithmic form and write them in exponential form. Pause the video, let's see what you come up with, and we'll take a look at your answers in just a moment. For 5 cubed equals 125, we're going to start with the word log. The base in this problem is the 5. The exponent is the 3 that goes to the other side of the equation. And we're going to put the 125 after the base. Log base 5 of 125 equals 3. For the other problem, we have log of 100 equals 2. If there's no base, we can assume that the number 10 goes here. This base is the number that goes first. The exponent is over here, that's this 2. So all of these numbers on the right side of these equations, that's by themselves, these are the exponents. And then what it's equal to is this value, that's 100. And we do have a statement that makes sense. Yes, 10 squared is equal to 100. Down here, our base is 3, our exponent is 4, and it's equal to 81. And indeed, 3 to the 4th power does equal 81. So now we can tell the difference between exponential and logarithmic forms. What we have here next is a whole bunch of exponential expressions you should probably know without a calculator. What's nice is if you know these without a calculator, it should speed up the process of getting homework problems done or math problems that you're working on done. These are things that you should know as easy as like 2 plus 2 or 3 plus 3. What I'd like you to do is in just a moment, pause the video, see how many of these that you can come up with without using a calculator. Now 2 squared is something I think you know. To come up with 2 cubed, multiply the previous answer by 2. 2 to the 4th, multiply the previous answer times 2. 2 to the 5th, you get the idea. See how many of these you know without using a calculator. Pause the video, we'll come back and we'll reveal all 20 of these answers in just a moment. So here's what our answers look like. For these powers of 2, you're just doubling numbers. You should be able to easily do that up through 64, no problem. 2 to the 6th power, your answer starts with a 6. 3 squared is 9, times 3 is 27, times 3 is 81. If you remember that this is just the same thing as 9 times 9, that makes 81 a little bit easier to come up with. 4 squared is 16. 4 cubed is actually the same thing as 8 times 8, which is 64. A little bit tougher to think of, but 2 to the 6th power and 4 to the 3rd are the same, so maybe that's a way of thinking of that. You should know 5 squared. 5 cubed is just 25 times 5. It's like having 5 quarters. The rest of these values should make sense as well. Powers of 10 basically are indicated by the number of zeros matching the exponent that you see here. We're now going to evaluate logarithms. Now, to evaluate a logarithm like log base 2 of 232, what I find works best is to set this actually equal to x. Now, I'm not very familiar with working with logarithms, probably like you, but what I am familiar working with is exponents. If we have a log base 2 of 32 equals x, this is written in logarithmic form, and you may remember earlier in the worksheet we were able to convert equations in logarithmic form to equations in exponential form. And that's what we're going to do here. I'm going to write this in exponential form. My base is 2. Over here is my exponent. And this is equal to 32. Now, what we're trying to figure out here is what is our exponent going to equal. And in this case, 2 to what power equals 32? Well, based on my expressions I know, 2 to the 5th power is 32. So x here should equal 5. Here's a logarithm problem that says log of 1,000. Again, we're going to make this equal x. If there's no base here, do you remember what number we use? Yep, we use 10. And in exponential form, we would write this as 10 to the x power equals 1,000. Based on values we should know, 10 to what power equals 1,000? 10 to the 3rd. So x here should equal 3. For the log base 3 of negative 9, again, we'll set this equal to x, and we're going to go 3 to the x power equals negative 9. Well, 3 squared equals 9, so you might be thinking, well, it's negative 2. No, 3 to the negative 2 power is actually equal to 1 over 3 squared, or 1 over 9. So, in all honesty, how do you get a negative 9 here? Well, you can't. There's no solution to this problem because you can't take a positive number to an exponent and get a negative result. So there's no solution here. Moving down here, our next problem says log base 8 of 4. Again, we're going to set this equal to x. 8 is my base, x is my exponent, and it's equal to 4. Now, 8 to some power equaling 4 sounds kind of tricky and confusing. Here's how we're going to handle this. Both the 8 and the 4 can be written as powers of 2. 2 cubed is equal to 8. 2 squared is equal to 4. So I'm going to replace 8 with 2 cubed. I'm going to replace 4 with 2 squared. And I'm going to put the equal sign and the x back where they were originally. Now I have 2 to the 3x power equals 2 squared. The bases are the same, so to make the exponents equal to each other, if the bases are the same, you can more or less cancel them out and solve this problem. 3x equals 2. I'm just saying this exponent here has to equal this one. Divide both sides by 3 and you get x equals 2/3. Same idea is true on this one. See if you could solve this one. Pause the video. We'll come back and see if you get the right answer in just a moment. To wrap this up, we're going to again set our logarithmic expression equal to x. 125 is my base. My exponent's over here, and this is equal to 5. Now, just looking at this, I'm not sure what the answer is, but I know that I can write 125 as a power of 5. We did that up here. 5 cubed equals 125. So I'm going to replace the 125 with 5 cubed. 5 is equal to 5 to the 1st power. So I'm going to write this so it has an exponent as well. And I'm going to put my equal sign in here, and my x is going to still be in the exponent. I want these exponents to be the same. The bases are the same. To get the exponents the same, we need to say that 3x equals 1. So it's kind of like the 5's kind of cancel, and you're left with 3x equals 1. Divide both sides by 3, and you get an answer of 1/3. Now, in all honesty, your answers here really shouldn't include x because there really wasn't an x in the beginning of any of these problems. We kind of added it in here. So really what you want to say is the answers for these problems are just the numbers themselves. So that's all I'm going to circle here are the numbers. These are actually the solutions to the problem. We really don't even want to have x in our problem, but it's kind of helpful and makes it a little bit easier to work with. In all honesty, your actual answer should be 5, 3, no solution, 2/3, and 1/3. The last thing we're going to look at today is something called pH and acidity. pH is a measurement that is used to determine whether food items or other substances have a high acidity or are they more of a base. Now there's a formula to calculate pH. It's equal to the negative log of H+, where H+ is the concentration of hydrogen atoms. In general, something that has high acidity has a high concentration of hydrogen atoms and conversely a low pH value. So something like lemons, which are very acidic, only have a pH value of about 2. Something with low acidity, like white bread, will actually have a low concentration of hydrogen atoms, which results actually in a high pH value. So white bread, not very acidic. You don't get a sour face when you eat white bread, and it has a pH value of 6. Now an apple, obviously not as acidic as a lemon, but still has some decent acidity. It's at 3.5 for a pH value. Our goal is to figure out what the concentration of hydrogen atoms is. So I'm going to go to my formula here. pH is 3.5. I'm going to write that in here. And it's equal to the negative log of the concentration of hydrogen atoms, H+. Now we had said earlier that if you don't have a base for your logarithm, you can assume that this number here should be 10. So you can write a little 10 in here if you want to. Now, this negative sign is going to give us a little bit of grief. So the first thing I'm going to do is I'm going to divide both sides by -1 or multiply both sides by -1. I just got to get this negative sign over to the other side here. So if you want to think about dividing both sides by -1, that's fine. When you do that on the left side, you'll get -3.5, and on the right side, the negative log base 10 of H+. To write this in exponential form, our base is 10. Our exponent over here is -3.5, and this should equal the concentration of hydrogen atoms. Now to calculate 10 to the -3.5 power, it's pretty easy. You have your 10 caret -3.5, and your answer is 3.16227766 e -4. We had said that when you see this e on your calculator, it means times 10 to that power, so it's about 3.16 times 10 to the -4th power. That's what the concentration of hydrogen atoms should be. The next problem is a little bit easier to solve. In this problem, we have a graham cracker. I'm given the hydrogen amount, 3.16 times 10 to the -8. We're going to solve for the pH value. So again, we're going to refer to our formula for pH, which is at the top of this page here. It says pH equals the negative log of H+. So pH, which we don't know, is equal to the negative log of 3.16 times 10 to the -8th power. Now if you're using a standard base 10 log, there is a base 10 log button on everybody's calculator. It's located here next to the 7 on the TI calculators. So this is actually really easy. You just type in negative. Here's our base 10 log, regular log, 3.16 times 10 to the -8th power. And when you type that in, you get a decimal of about 7.500. I'm just going to round that to 7.5, and that's your pH value for the graham cracker. And that wraps up our notes on logarithms and exponents.